Welcome. In this video we're going to review for the graphing trig formative. Alright, so we want to find the amplitude of the graph shown. Now amplitude is the distance from the middle of the graph to the maximum value or the middle of the graph to the minimum value. So we can see here that this graph is not shifted up at all. Right here is the midline. Notice, and that midline is y equals 0. Half the graph is above and half the graph is below. So whether you look above here or whether you look below, you get the same answer. The distance between the midline and the maximum or the midline and the minimum is 3. So the amplitude for this graph is 3 units, or just 3. All right, let's try another problem. All right, so amplitude, as a reminder, is just the distance from the midline to the maximum or the midline to the minimum. It is not the difference between the maximum and the minimum value. Right? It's half that value. What's the period of the equation? Right, so let's find all of the parts to this. So the amplitude, and that'll help us review. The amplitude is the coefficient in front of sine or cosine, so the amplitude is 4. The period, which is what we're looking for, is going to be 2 pi divided by b. b equals the coefficient on x. So in this case, right there is b. b is 2 pi thirds. So to find the period, we're going to take 2 pi and divide by 2 pi thirds. Right? It's not the x, it's the coefficient on x. If we're dividing by a fraction, that's the same as multiplying by the reciprocal. So this would be 2 pi times, and if you want, put a 1 under it, to, as a placeholder. 2 pi times, you're going to flip the 2 pi thirds, and that'll be 3. And so the 3 is in the numerator, the 2 pi is in the denominator. So our period is going to be 3. Right? Because the 2 pi's will cancel. This graph also has a phase shift. Right, so since b is factored out of the parentheses, the phase shift is what's added or subtracted to x. Now remember, this goes with the equation. That subtraction sign goes with the equation. So if we see minus pi halves, that means pi halves to the right. If we saw plus pi halves would be pi halves to the left, right? So, but that is to the right. And then the vertical shift is what's added or subtracted to the whole function. The sign is what you see. So here we have plus 4, so that's 4. I should actually just put 4 units up, I suppose. Or you can put 4 up or 4 units up. Sounds better to say 4 units up. And there we go. So the answer to the question was 3. We found the period by taking 2 pi and dividing by b. But since we were able to answer amplitude and phase shift and vertical shift as well from this equation, I figured it was a good opportunity to review those 3 things. All right? So amplitude, as a reminder, is the coefficient in front of sine or cosine. Period is found by taking 2 pi dividing by b. Phase shift is what's added to x after b's been factored out. But remember, minus means to the right, plus means to the left. And vertical shift is what's added to the whole function. If it's a positive, it's up. If it's a negative, it's down. What's the period and equations of the asymptotes for f of x equals tangent 3x? Let's find both period and the vertical asymptotes. To find period for tangent, so to find period for sine, it's 2 pi divided by b. Or to find period for cosine, it's 2 pi divided by b. To find the period for tangent, it's just pi divided by b. Because normally the period for the period for tangent is pi. Right? The distance between those vertical asymptotes, if the tangent graph has not been transformed at all, is pi. All right, so we have to identify b. b is the coefficient on x. It's right there, so b is 3. So that means the period is going to be pi divided by 3. That's all there is to that one. Let's find the vertical asymptotes. And one of these questions is on the formative. Either it's finding the period or finding the vertical asymptote. You'll have to take the formative to find out which one it is. To find the vertical asymptote, always we take bx and set that equal to negative pi halves, half of the period. Right? Because on either side of any period of the tangent graph is a vertical asymptote. So one period of the tangent graph is just the distance between those any two vertical asymptotes. To find them, you're going to take bx equals negative pi halves and bx equals pi halves. Because normally those vertical asymptotes are at negative pi halves and pi halves. If you go and change the period, you're going to change the vertical asymptotes. So b is still 3. So we have 3x equals negative pi halves. All right, so now if you want to isolate x, and that's what you'll need to do to solve for the vertical asymptote, you could divide by 3. The problem is you have a fraction on the other side, right? And it's kind of hard to divide by a fraction. It makes more sense to multiply by the reciprocal. So instead of dividing both sides by 3, simply multiply both sides by the reciprocal. And do that all the time for these graphs, because our expression on the other side is always a fraction. It's always pi halves or negative pi halves. So we have 1/3 times 3x equals 1/3 times negative pi halves. Somehow I always end up at the bottom of the page. Let me just move this up just a little bit. Actually, let's do, yep, there that goes. And let's see if I can revolve this up. There. Now we can see what I'm doing. We've got some space. All right, so we're going to multiply both sides by 1/3 to isolate x. So we have 1/3 times 3x equals 1/3 times negative pi halves. 1/3 and 3 cancel, so that's just an x. If you take 1/3 of 3, that's just 1. And 1/3 times negative pi halves, multiply the numerator together. So 1 times negative pi is negative pi, and 3 times 2 is 6. And there we go, x equals negative pi 6. Let's do the same thing on the other side. All right, so we've got 3x equals positive pi halves. We want to isolate x. Instead of dividing by 3, just multiply by the reciprocal. Right? So to make it easier to work with the fraction on the other side. So 1/3 times 3x equals 1/3 times pi halves. The 1/3 and 3 cancel, that's just an x. And 1/3 times pi halves, 1 times pi is pi, and 3 times 2 is 6. And there we go. There's our vertical asymptotes. So the period is pi thirds. The vertical asymptotes are negative pi 6 and pi 6. Notice that the distance between them, so if I was to take pi 6 and subtract negative pi 6, oops, that's my parentheses there, that would give us pi 6, so minus a negative is a plus. Wait a minute, marker's taking the time to get up here. And pi 6 times pi 6 is 2 pi 6. And the absolute value of 2 pi 6 is just pi thirds. So notice that that distance between the two vertical asymptotes is the exact same thing as the period. Right? I think that's what, 3 down? Maybe 2 more to go. All right, so what's the equation of the graph shown? Right? You'll have a similar problem, except you might have an equation and then which is the right graph. I'm going to go from the other direction and give us the graph, and then we'll figure out the equation. All right, so notice, first of all, that none of the graphs have been shifted horizontally. There's no horizontal shift in any of these graphs because nothing is added to x. All right, so I can write this equation one of 2 ways. If I write it in terms of cosine, that is a period of cosine, right? It starts at its maximum, goes to its minimum, and comes back to its maximum. I could also write it in terms of sine. Sine starts at its, sorry, too far over. Sine starts at the x-intercept, not the minimum. All right, it goes to its maximum, back to the x-intercept, to the minimum, and back to the x-axis. So here we have the graph of 1 period of sine. That graph would have to start here, and then 1 period would end here. If we look at it from cosine's perspective, cosine would start at its maximum. So this would be 1 period of cosine. If you notice, and either one of these would be correct. We could write this equation in terms of sine, because sine and cosine are actually just shifts of one another. However, we could not write this graph in terms of sine based on the choices that we have, because none of these have anything added to x. So this cannot be sine. Has to be cosine. So if you're determining between sine and cosine, look to see if your choices have been horizontally, have a phase shift that's not 1. And take that into account. Here, we have to use, that has to be our graph right there. Actually, I'll outline it. Because none of my choices have been shifted horizontally. There's nothing added to x. So that is 1 period of our graph. All right, so notice it starts here at 0, and it ends here at pi. All right, so the period, so this is definitely cosine. The period is equal to pi. So now we're going to have to figure out, how do we get a period of pi? How about, and there's no phase shift, how about amplitude? Is there an amplitude change? All right, so let's find the midline. That'll tell us. The midline divides the graph in half, and it is what the graph is oscillating about. It's going above and below that particular line. Right? If we look at that, the amplitude is the distance from either the midline to the maximum value or the midline to the minimum value. That distance is only 1. So the amplitude of our graph here is 1. Right? So the vertical distance from the midline is 1, whether I'm looking at the maximum, looking at the midline to the maximum, or if I'm looking at the midline to the minimum. Right? That amplitude is 1. How about a vertical shift? The easiest way to figure it out is take a look at This is where your old midline is. This is y equals 0. Right? So before the graph has been vertically shifted, it's obviously vertically shifted because it's not oscillating around 0 anymore. Right? Before it's been shifted, that's the midline. Now let's look where the midline is. 1, 2, 3, 4. So now the midline is 4. That means the vertical shift is also 4. So the vertical shift is the same as the midline. So now let's go through our choices and eliminate some. All right, so we said it can't be sine because it's not shifted. Sine would have to be shifted and start at negative pi fourths. Let's add that to our information here. So sine would start at negative pi fourths for this particular graph, right? Because right there would be the start of sine. So we can eliminate A and we can eliminate C. We can also eliminate C because the vertical shift is wrong. Right? They wrote the vertical shift from the top of the graph, not the midline of the graph. So that's not the correct vertical shift. The graph hasn't been shifted up 5, it's only been shifted up 4. So that's wrong anyhow. Let's figure out the period. Right? Now, I think the amplitude gives it away, but let's make sure that I wrote a good equation, because let's make sure it matches the period. Because what if these had the same amplitude and it was only the period that we could use to distinguish which one it was? All right, so to determine the value given the period on the graph, let's think back to how we got this period. All right, so to find the period of cosine, we take 2 pi and divide it by b. Now when we divide 2 pi by b, in this case, we got pi. Right? So now we want to solve for b here, and I think you can probably figure it out, but let's just actually go through the steps of solving for b. All right, so to get b out of the denominator there, we're going to multiply both sides by b. All right, so that will cancel out the b. So now we have 2 pi equals pi b, or b pi, however you want to say it. All right, now we're solving for b, so we're going to have to divide both sides by pi, and when we do that, we see 2 is b. So that means this value here should be a 2, because that's b. Here, b is 1. And the amplitude is 2. Well, that's wrong, right? Because we said the distance from the midline to the maximum value or the midline to the minimum value was 1, not 2. So that's wrong. This is the one that's correct. It's got the correct b value. B is 2. If we take 2 pi and divide by 2, we do indeed get pi. And this right here is 1 period. So you can see the graph is finished by pi. The graph's been shifted up 4, that's correct, and the amplitude is 1. So everything about y equals cosine 2x plus 4 is correct, and all the others have something wrong with it. Okay? So go through step by step, don't just eyeball it. Find one period of the graph and match the equations to the features. Or if you're going the other direction, then take your equations and identify. So first of all, identify what's the key features of the equation, and then does your graph match it, right? So if we were given a bunch, if our equation, for instance, was y equals cosine 2x plus 4, we were given a bunch of graphs, we're going to look first of all for the graph that has an amplitude of 1 and eliminate anything that doesn't have an amplitude of 1. We're going to look for the graph that has no phase shift. We're going to look for the graph that's got a period of pi. Right? And so we'll just keep eliminating anything that doesn't meet those requirements. Right? Last one, domain and range. What's the domain and range of y equals 2 sine 4x plus 3? You'll be asked one of these questions on the formative. Let's go over both of them. if you miss domain, I might cry a little bit. Because every single time, all the time, no matter what is done to the sine or cosine graph, its domain is negative infinity to infinity or all real numbers. Those should be parentheses, not brackets, because you can't actually reach negative infinity or infinity. That just means to grow without bounds. So there are no x values that are eliminated from the graphs of sine or cosine because they just keep doing the same pattern forever and ever and ever and ever and never ever stop. Let's find the range. The range is a little harder. We're going to use our table of values, but we're not going to necessarily fill in every value because we don't need to. So if you remember, our table of value has 6 columns. But not everything on this table affects the range. The range has to do with y. And so only things that affect y are going to affect the range. So we don't have to worry about anything that affects x. Now I will fill in the old x value, the starting x value, just because, actually, it might not be a bad idea to fill in all of these for this particular graph. Oh, what the heck. We'll fill in all of the columns. It won't take us that long. So old x, now this is a good review for homework. Old x all the time is 0, pi halves, pi, 3 pi halves, and 2 pi, going around the unit circle. This is sine. When x is 0, sine is 0. At pi halves, sine is 1. At pi, sine is 0. 3 pi halves, sine is negative 1/2. And at 2 pi, sine is 0. All right, so we've got period. The period for this graph, all right, so b is the coefficient on x. So the b is 4. So period is 2 pi divided by b. That would be 2 pi divided by 4, which would be pi halves. All right, so it takes pi halves for the graph to go through all of its values. That does change the x. To find our new values, we start at 0. We take the period and divide by 4. So that would be the same as pi halves divided by 4. Dividing by a fraction is the same as multiplying by the reciprocal. So this would be pi eighths. So we're going to count by pi eighths from 0. So 0, pi eighths, 2 pi eighths, which is pi fourths. My numbers are too big. We're drifting. 3 pi eighths, and 4 pi eighths, which is pi halves. Let's just squeeze it in there. All right, and pi halves is exactly what the period is, and our last value in the table needs to match the length of the period. There, I'm just trying to squeeze everybody in. Next would be the phase shift, but there is no phase shift. Nothing's added to x, so this is done. So if we were graphing, those would be our x values. To y, you multiply by the amplitude. The amplitude is the coefficient in front of sine, right? I don't have any room to write anything anymore. I'll squeeze it here. All right, so amplitude is 2. So we're just going to multiply these values by 2. Oops, not negative 2, just 2. So that's going to be 0 times 2, 1 times 2, 0 times 2. All right. Move everybody up. We're falling off the graph here. Negative 1 times 2 and 0 times 2. And then the vertical shift, Vs, is 3. And this is 3 up. So we would add there was squeeze some space in here. We would add the vertical shift after we multiplied by the amplitude. So we would just be adding 3 to all of these values. So that would be 0 plus 3 is 3, 2 plus 3 is 5, 0 plus 3 is 3, negative 2 plus 3 is 1, and 0 plus 3 is 3. And this gives you your range. Here's our low value. Here's our high value. If we were graphing, this would be our y values. So the range, and this does have a bracket because the graph does go through these values, is 1 to 5. Right? So if you were asked for domain, it's always negative infinity to infinity. If you're asked for range, you actually don't need the x, the period, or the phase, because they have nothing to do with y. So long as you remember that sine is 0, 1, 0, negative 1, 0, and cosine is 1, 0, 1, 0, negative 1, 0, 1. Only the amplitude and the vertical shift affect the range. We multiply by the amplitude and then add the vertical shift. So the range is 1 to 5, but the domain, and it will never change, is all real numbers. And I think this is my last one. Yep. I just have a random extra page on there. So thanks for watching. Good luck on the formative, and bye for now.